y squared equals 1 over y squared. Congratulations, Kyle. Go ahead and say QED and push your glasses up.
QED.
Nice. Well done. See, it happened.
Barely.
All right, so this is the last Pythagorean identity. So I'm going to put it down in my chart. All right, that is, it was what? 1 plus cotangent squared theta equals cosecant squared theta. And then I'm going to show you one example of how to use it. And then I'm going to give you 3 problems in your homework, and that'll be it. Okay, maybe I'll give you a few more. Good point, Kyle.
Can you explain the last step you did?
Yeah, so y squared plus x squared is the same thing as sine squared plus cosine squared. And we already know that sine squared plus cosine squared, because of the Pythagorean theorem, equals 1. So I just replaced this and this. Okay, so we're going to do one example of this. And it goes like this. So let's say that cosine of theta equals negative square root of 3 over 4 and is in the second quadrant. It's supposed to be an S. Okay, and I want you to find sine theta and tangent theta. Okay, now we're only going to use the formulas we know. Now, again, these are the only 3 formulas we know. So I feel like we are going to really figure out which ones to use, okay? There's only 3 of them. There's only 3 of them. Notice how the first one has sine and cosine in it. The other one has tangent and secant. The other one has cotangent and cosecant, right? And so far we have cosine. So which one do you think we should use out of those 3? Probably the one that has the cosine in it, right? So I'm going to write down sine squared theta plus cosine squared theta equals 1. That's the identity I'm going to use. And then instead of writing cosine squared, I'm going to fill that in. So I'm going to write sine squared theta equals, plus parentheses, negative the square root of 3 over 4 squared equals 1. So basically, I just put in, instead of cosine theta, I put in what it is. Now I've got to square it. So what's a negative square root of 3 squared? Positive 3. And what's 4 squared? So this is now sine squared theta plus 3/16 equals 1. Now what should we do to get sine theta by itself? Yeah, I'm going to subtract the 3/16. Can you tell that because I'm going to have to subtract the 3/16 that I should really change this into 16 over 16 to make that easier? So now I've got sine squared theta equals what? 13/16. And now how do I get sine theta by itself? I want to get rid of the square. So I do a square root on both sides. So now I've got sine theta equals the square root of 13 over the square root of 16, which is, what's the square root of 16, everybody?
4.
4. And now the big question is it going to be positive or negative? It's in the second quadrant. Can you think about sine right now? Sine is what, x or y? Y. Is y positive or negative in the second quadrant? Positive. Yep. Because if I do the square root of this whole thing, I have to do the square root of the top and the square root of the bottom, and the square root of 16 is 4.
Wait, so how is,
But now I've only gotten sine so far, right? And I still need tangent.
what's so more?
Oh my gosh, this is a nightmare. Thomas?
So why does the 13 say as 13?
Because, so, okay, maybe I should have written this step out. This is the square root of the whole thing, right? Which is equal to the square root of the top divided by the square root of the bottom. And the square root of 13 isn't a number. I mean, we can't even break it down like a factor tree, right? But the square root of 16 is 4. So it's not like I left it at 16, I just said the square root of 16 is 4,
So
yeah?
that's the top.
So if the top is prime, or you can't break it down,
Then
then you leave it. Yes?
Oh, you can't just put it in your calculator?
No, I don't want a decimal up there, because a fraction would be weird if you had a decimal on top of a fraction. So just leave it as a square root. Okay,
Can you have a fraction and a fraction?
yes, but usually you have to simplify it then. Okay, so now I know cosine is this, and sine is this, but I still need to find tangent. How do I find tangent if I already have cosine and sine?
Plug it in for the one.
How is tangent made out of cosine and sine? Emma? Tangent is sine over cosine, and if you're like, how the heck am I supposed to know that? Units, this is just, it's your baby, okay? Look at it. If you're like, boy, I don't know how to solve this problem, let's take a look. Maybe it's on here. Tangent is sine divided by cosine. See, it's right there.
Oh,
You wrote it. You wrote that on there.
wait.
Tangent is sine divided by cosine. So I'm going to write it out. Tangent of theta equals the square root of 13 over 4 divided by negative the square root of 3 over 4. So what should I do now? Flip and multiply. Square root of 13 over 4 times 4 over the square root of 3. That one's a negative. 4's cancel out, right? My answer is going to be negative square root of 13 over the square root of 3, but that's not good. Because
There's a bottom.
that stupid rule that I hate so much. So we're going to rationalize it. Because we have to. Which is negative the square root of what? 39 over 3. And that is tangent. I really think 3 problems will do you.
Yeah. Yeah.
Most definitely. Okay, can we write out the whole assignment now? Just to make sure we're all on the same page. So, tell me what I have told you so far.
You have said.
What was day 1?
Page 518. 13, 15, and 16.
13, 15, 16? Okay. That was at the first day? Okay. Second day?
Page 533. 53 through 70.
53 through 70?
No, 63.
63 through 70. And that was all?
It said 6 yesterday.
What?
It said 6 yesterday.
Okay. And then today, we're gonna add in page, I'm gonna add to, this assignment, numbers 139 through 141. And, ooh, I'm gonna add one more. I'm doing it. It's tragic, isn't it? And we're gonna count this as 2 different assignments tomorrow, so the page 18 assignment will be go in the gradebook once, and the page 33 assignment will go in the gradebook once. Let's also put in, I'm gonna add to this one, number